Given a non-empty array of integers, every element appears exactly twice except for one. Design an algorithm to find that element. That's about today's video. Let's dive in. San Francisco Bay Area, or Silicon Valley. This is where my dream started. Hi everybody, this is Steve here. Today we're going through another labeled as easy. It's actually pretty easy, but it's good to brush up on your CS fundamentals and the basic understanding of a few very basic computer science concepts. It's called single number. Let's quickly go through this problem first. Given a non-empty array of integers, every element appears exactly twice except for one. Find that single one. There's a note here. Your algorithm should have a linear runtime complexity. Linear, which means in big O notation is going to be ON, which means we are not allowed to have a nested for loop or a double while loop, something like that. So could you, and another note is, could you implement it without using extra memory? All right, two notes. Let's take a look at the examples. One example is 2 to 1. 2 appears twice, so the single element that appears only once, which is 1, so it returns 1. The second example is 4, 1, 2, 1, 2. So 1 appears twice, here and here. 2 appears twice, here and here. Only 4 appears only once, so we return 4 here. A brute force solution, which is going to use a, it says without using any extra memory, which in other terms, the most intuitive solution is going to take advantage of an extra data structure so that we can return the result. We can either use a HashSet or a HashMap. HashSet should be good enough because we're just say if every single element in this given non-empty array appears twice, we'll just keep adding all of the elements into this hash set. While adding the element into the hash set, we'll do a check, say if we can add this element into the hash set. If we cannot add it, we'll just remove that, which means this is the second time we encounter the same element. While in the end, there should be only one element that's still remaining in the hash set. We'll just return that, right? This is one solution, but apparently it's not meeting the requirement. It says, could you implement it without using extra memory? Well, think about how we can implement an algorithm which is only using linear runtime complexity, which means we cannot go through have a nested for loop, which means this is so basically this question has very good stringent requirement on both time complexity and space complexity. You see, time complexity is ON. You cannot trade off between time and space. Usually we sacrifice space for time or sacrifice time for space. But for this one, there is a way that you can do very optimal in both time and space. So if we don't take advantage of an extra data structure, what do we do? If you just click related topics here, one is a hashtag, the other one is bit manipulation. All right, bit manipulation. This is the key computer science concepts that we would like to go through today, which is what is bit manipulation. So bit manipulation, let's go through a few basic concepts. One important bit manipulation is exclusive OR, which some people refer to exclusive OR here. What this one, and this is actually the operation that we're going to apply in this to solve this problem, which is going to give us ON linear time complexity and without using any extra space. So what is exclusive OR? In simple terms, it's comparing the bit. Every two bit is going to compare. If these two bits, they are the same, then that's going to return us a 0. Whether it's 0 or 1, as long as two of the two bits are equally 0 or equally 1, then the result, the exclusive OR results of the two bits are going to be 0. So what does that mean? How do we compare? Okay, we'll have like say 1 here. 1 and B which stands for two numbers, and C is standing for the result. Let's call it this way, and result. And this is how we're going to illustrate this. Say 0 exclusive OR. So exclusive OR. This is the highlight this one. This is the symbol of exclusive OR in computer science, which is just a strike here. So let's put, as I just said, if these two bits are exactly equal, either they are 0 or 1, the exclusive OR result is going to be 0. The same is true for one exclusive OR with 1 is going to be 0. However, if it is 0 exclusive 1, then it's going to become a 1. Or 1 exclusive OR 0 is going to become a 1 as well. Because these two bits are different. 0 minus 0 exclusive 1, these two bits are different. That's why it's 1. And these two bits are different. So that is why this is 1. And these two bits, they're both 1, regardless whether they are 0 or 1. So the exclusive OR result of these two bits is 0. So is this one. These two bits are both 0, so the result is 0. So how does this really apply to this problem? This problem is asking us to find the single element that appears only exactly once, while every single other element appears twice. Okay, let's take a further look at one more example. See, how do we? So in computer science or in your computers, every single numbers or every single characters is represented in binary. So let's see. Let's just use this example. The example here is 221. So 221. So how do we represent 2 in binary? In binary form is what? Is 1 0, right? Because okay, so 1 in binary form is 0 1, right? And in binary there's only 0 and 1. So we'll add 1. 2 is greater than 1 by 1. So we'll add 1 to this one, which is going to make this one become a 0 and this one becomes a 1. So that's why 2 in binary form is 1 0, right? Don't read this one as 10. That's not 10. It's just binary form of 2. Okay. So and then here another, so we have these 3 numbers, another 2 here. So now what we can do, how we can use exclusive OR to find that single number which appears only once. Let's see. A very simple strategy is, if you can see, so here let's do 2, this is in decimal format, so 2 exclusive 2, which is going to give us 0. Why? Let's put the 2 into binary format. You'll have a better understanding. As I said here, 2's binary format is 1 0, right? 2's in binary form is 1 0. So what we're going to do is 1 0 1 0. So this is a 2 and this is a 2, right? And so it's exclusive OR is doing bit by bit comparison. So the result of this is this. So the result of this is why we're comparing bit by bit, vertically, bit by bit. 1 compare with 1. So 1 compared by 1 compares with 1 is going to give us 0, right? So this one is 0. And then we have 0 compares with 0 on the same bit. So 0 compares with 0. This is 0. And this is still in binary, and we transform the binary format into decimal format. It's going to be a 0, right? This is how we get the result of 2 exclusive OR with 2, we get a 0. Actually, this format applies to all numbers. Every single number does an exclusive OR with itself is going to result with a 0. Why? Because, as we said, every single number, and all when transform that decimal number into binary format, it's always going to end up with exactly the same binary representation, right? Which means every single number's binary bit at the same position is going to be exactly the same. It is either both of them are 1 or both of them are 0. then we do an exclusive OR by bit, then we can see it's always 0. If let's just walk through one more example. Say 3 exclusive OR with 3 equals to what? How is 3 represented in binary format? Let's see. 2 is here, so we'll just add one more 1 into 2. So 3 is 1 and 1. So 3, 1 and 1. Then we do a exclusive OR for these 1 and 1. What's the result? 1 and 1, we compare 1 and 1 is going to give us 0. So this one is 0. 1 and 1 again, 1 and 1 is 0. So what's the result? The result is 0. That's why the result is 0 here. So this applies to all numbers. As I just said, every number does exclusive OR with itself is going to result in 0 because every single bit is exactly the same. And for exclusive OR, if these two bits are equal or the same, we're going to get a result of 0. Okay, and after that explanation, then we go back to this problem, single number. How we can apply this this idea into this single numbers problem, which is very straightforward, right? Every single number does exclusive OR with itself is going to become 0. And the only remaining bits is going to be the single number that's left out, which appears only once in this array because it doesn't have another number of itself that can balance off all of its bits. Then we'll just return that number, right? Very straightforward. All right. With that said, I hope we're all on the same page, and then we can start writing the code. First, we'll just quickly implement the brute force solution, which is using extra memory. As I said, we can use a HashMap or hash table. HashSet is easier. We'll just go with that, implement that, and then we'll implement the bit manipulation. Let's see. So here, set, we'll call it integer, set new HashSet. And then for, we'll go through into nums, we'll go through all of them. Check if set, we'll check if we can add this number into this hash set. If we cannot add it, we'll just remove this one from the hash set, right? Because if we cannot add it, that means this is the second time we encounter this number. Otherwise, this condition will not hold. It's not going to come into this this parenthesis, this branch. So let's save. That's it. And then here we can just we only need to return the last element in this hash set, which is what we're going to return. We can use an iterator and then call it next because there is actually only one element remaining in the set. Now let's submit. All right, it's accepted. That's cool. This is the kind of suboptimal solution because we used an extra data structure, extra space, extra memory, which is not desirable. But so let's reset it to default and let's just use the bit manipulation. How do we do that? As we just said, we just went through this. We'll just go through this entire given array list only once and do exclusive OR for every single number. Just go through that one by one, and the only remaining one is going to be the one that's going to give us the return, because that's the only number that doesn't appear twice. That's it. All right, let's call it a result. Just call it 0. Then for int nums, we'll just do result exclusive OR here, num, and then we'll just return result. That's it. So this is doing a result with every single number in this array list. Now let's submit. All right, it's also accepted. Much better. Runtime is 0 millisecond, faster than 100%. That's cool. That's the bit manipulation. I hope this serves as a good explanation to help people really understand a very basic or very foundational, a very important and critical computer science concept, which is bit manipulation and exclusive OR. If you feel you like this video, please do me a favor and gently tap the like button. That's going to help a lot with the YouTube algorithm. And also don't forget to subscribe to my YouTube channel. That's it for today's video. I'll see you guys in the next one.